Hey there, everybody. Welcome back to Coding at Home with the Code Hub. We're about to start on a brand new chapter today in the Everyone Can Code Puzzles book. And let's tell you a little bit about it. So today we're going to start talking about logical operators, which sounds maybe a little bit frightening if you haven't done any computer programming before. But at this stage, this is day 17. So you can say you have actually done some computer programming before. And this is going to bring us back to that time when we were doing conditional coding. And we used the if, and else statements to run our code and to run code depending on the scenario we were confronted with. In the case of Byte in the puzzle world, we would check to see if we were blocked. There was an is blocked property we could check. There was an is on gem property we could check. And all of those we could use in our conditions to do different actions depending on what state we were in. So with logical operators, we're just beefing that up a little bit. We're not just relying on one Boolean variable, because that's what we were using, if you remember. We're using Booleans. We can now combine them. So we're going to use some of these logical operators that we can see over here. And we're going to write code that looks a little bit like this. So here we have an example of it's not pseudocode, it's actual code where I check two different conditions with one if statement. So I say if is raining, and then I have those two ampersand symbols, and that stands for and. We're going to get into that in a second. And it's not windy. That's what that exclamation mark in front of the is windy property is telling me to do. We're looking to see if it's not windy. Then we're going to bring an umbrella. Otherwise, we'll leave the umbrella at home. So this allows us to check for two different conditions, because we're not always able to just toggle based on one condition. Maybe we want to consider multiple different conditions before we run some code. And we're going to see that when we get into the exercises today. So that's the and logical operator. There's also an or logical operator. But you can see that this is just another tool for us to write code that does things a certain way. So there's two different implementations here of me handling the weather and trying to decide whether or not to bring an umbrella. And in one, I use the and logical operator and the not logical operator. And then in the other one, I just use a plain old if, else statement. So this is all down to how we design our code, and it's going to differ depending on how you think about the problem. You may have framed it in a different way. You may have named your variables in a different way, so that instead of is raining, you could have named your variable is dry, for example. So we're going to get back to the book, though, and then we're going to jump into some playgrounds and play around with these things. So let's go take it to the book. All right, so we'll open up books. And now we're still in the functions with parameters chapter, so I'm actually going to flip through this. I'm going to go back to the table of contents and swipe over to chapter 8. So it just tells us a little bit about logical operators and or and not, right? And you can see over here that they define them over here. So the and operator is those two ampersands. The not operator is this exclamation mark that goes in front of the condition you're trying to test. And then the or operator, which is these two pipes. So basically it's kind of reiterating, we want to be able to test out scenarios where things are a little bit more complex than just true or false. Maybe we want to say, okay, well, cool, we can't go this way. And then we have a choice. We can either go this way or that way. Driving directions is a great example of this. And I'd love for you to think up some own examples in your own world. So maybe it's a dinner decision that you have to make. If you have one type of food, do you have another one as well, or do they not go together? Write them down. In some of these courses, particularly the app development with Swift course, we try to keep a thing called an app journal, where we write down instances of these different concepts that we get introduced to, and we try to see how they match our everyday experience, and it just helps bring home some of these concepts a little bit better. All right, so we're not going to go through this because I can do someone says round 2. I have no idea what you're wearing or what, any of that stuff that's going on. This is a great activity for the classroom, though, if you're a teacher watching this, trying to figure out how you incorporate this into your classroom. So here it tells us which playgrounds we're going to go play around with. So we go back to Learn to Code 1. We've been playing around with the slightly more advanced playground, Learn to Code 2, the last few sessions. We're going to go back to Learn to Code 1 and look at the logical operators chapter. So let's do that now. So we're going to exit out of here. We're going to go to Swift Playgrounds. We can see that I'm still in Learn to Code 2. I'm in my boxed in lesson. This is where we were trying to refactor our code a little bit. You can see we were using conditions, right? So if we were on a closed switch, we would toggle the switch. Otherwise, if we were on a gem. No, sorry, this isn't my Learn to Code 2. This is my Learn to Code 1. So if you're not in Learn to Code 1, let's exit out of there. If you don't have this one downloaded or you can't find it, it might be further down the screen. So if we scroll down a little bit, we wait for Swift Playgrounds to catch up with us here. Here we go. We're running a little slow as it tries to download some of the playgrounds that are running on other Swift Playgrounds instances with this account logged in. All right, so we have our Learn to Code 1. Yours may have fallen down here below the fold. If you can't find it, just go over to See All. Tap on See All. And we're going to grab this very first one, Learn to Code 1. So I'm going to go back to my playgrounds. If you've gotten that, hopefully that's downloading now for you. Now I'm going to open up Learn to Code 1, my copy of it. Right, and as I was saying, we're in boxed in. This is where we left off last time. So if we tap on the table of contents here, we'll see that we're just finished with conditional code in Learn to Code 1. And the very next chapter is logical operators. So this is where we're going to jump into this one. So we're going to tap on the introduction for logical operators. Okay, so it starts us off, like I said, I really like these introductions because they usually bring home the concepts. And they're worth rewatching over and over again, and also being patient because there's some animations that come in after you've landed on a page. Right, so we go back over the fact that we saw a condition before and we used an if statement for that. If the light is green, move forward, otherwise wait. Now there might be other conditions that we want to account for, especially when we're crossing the street. So this kind of explains some of the terminology here. So an operator is a symbol which represents an action. So we have this equal sign. We've seen that when we used a variable, we assigned a value to a variable. We did some addition here that we saw in the animation with the plus symbol. And then this ampersand will make your condition have to match both values. And let's go into that now. So these are the 3 logical operators that we're going to focus on. There are others that you'll get into more when you further your programming career, but these are the ones that you start off with and probably the ones that you use the most. Like I said, this is the AND, this is the OR, and this is the NOT operator. So the way that the AND operator works is that this particular code will only run if everything is true. So we have to be both blocked and on a gem. So in that case, we would run the code collect gem and turn around. Let's see what that would look like in our coding language. So this is what it would look like if we actually wrote the code if is blocked and is on gem, collect gem, and turn around. And we're going to use that in one of our playgrounds today. Let's go on to the next one. So the OR operator is if you want to handle a case where you only mind if one or both of the conditions is true. So in this case, we're saying, hey, if we're on a gem or on a switch, we'll do a dance. And this is what that would look like in code. So byte's going to dance if either condition is true or both conditions are true. So if we're on a gem, we'll dance. If we're not on a gem, but we are on a switch, we'll dance. If we're not on a gem and not on a switch, we won't run this code. When we get into these logical operators, this is where we have to really kind of take a moment to think about what it is we're trying to do with our code. And we figure out, okay, well, how are we trying to solve this puzzle or accomplish this task? We really have to slow down, spell it out. Thankfully, the way you kind of say these things, you say the ampersand or you say the exclamation mark, it reads like an English language sentence. So in this case, if we're not blocked, then we're going to fly away. And this is what it would look like in code. So we put that exclamation mark in front of our Boolean variable is blocked. So it might look a little bit frightening, but we're going to walk through it nice and slowly. We're going to work on beefing up some of our conditionals, and we're going to see how they can help us solve problems. Okay, so our very first one, when we tap on that start coding button, is using the not operator. So as it states up here in the goal, we're going to use the not operator to adjust our character's path when there's no gem on a tile. So if we read through the description, they ask you to run this playground a few times. So if we run our code, we're going to wait for it. We haven't written any code yet, but what we can see is that the stairs and the gems could show up anywhere. And what we do is we have a loop here that says, okay, so for 4 times, we're going to move forward, like we just saw Hopper do. Now, it's asking us to use this logical not operator. So if we're not on a gem, it says that there should be stairs. So when there's not a gem, there are going to be stairs, and then to our left, we're going to go down and then collect the gem from there. And then we probably need to get back if we're inside a loop. So let's try this out. So we have move forward. I'm going to tap at the end of the brace there and hit return. And I'm going to use my if statement from my autocomplete bar down here. Okay, so we're going to use our exclamation mark, right? Because we want to test if it's not blocked. So we're going to go down, bring up the keyboard from the menu over here. And there's our exclamation mark. So I'm going to tap on this key and drag down. Okay, cool. And I'll close the keyboard. And I want to test if it's not blocked. So I'm going to tap on that, is blocked. So if it's not blocked, what do we want to do? We want to turn left. We'll be, in this case, we'll be facing this way. We want to move forward once, twice. So we'll move forward once, twice. We'll collect the gem. Now, one thing to note, we're back dealing with just functions, right? This isn't a move forward here and collect gem. They aren't functions on my instance of Hopper because we've moved back in the material a little bit to an earlier playground. You remember we've been calling expert.moveForward or character.moveForward in our later playgrounds. All right, so we've collected the gem. We probably want to get back up here and then turn left again before we restart the next pass of the loop. So let's do that. Let's turn around So we'll turn left and then turn left again. Now we're facing up this way. We're going to move forward twice. And now we're back at the top of the stairs. We want to turn left again. So let's turn left. So now we're facing this way. We've gone and collected this gem. So if we were not blocked, do you think this is going to be the right code though? Is blocked the condition we want to test? So let's try running it and see what happens. All right, we get regenerated. Okay, we weren't blocked. Okay, so maybe we're not testing the right thing. Let's go fix this condition. So what do we want to do? We want to have Hopper go forward. What's the test that we can run here? We want to test to see if we're not on a gem. All right, so let's change that condition that we're testing. So if we're not on a gem, that's when we're going to turn left. Okay, let's try running that. All right. Well, so we're not on a gem to start with. Okay, all right. Okay, so there's a bug. How are we going to fix this? How are we going to get byte off of this first tile before we even start? Well, we could have done this code here after move forward. Let's try that out. Let's tap on that. All I did there was I tapped, so we had it down here. I tap on the function name and press and hold it. Then it turns a slightly darker blue. And then I'm gonna drag up. You can see the cursor is showing me where it would drop it. So I'm gonna drop it up top. So now what I'm gonna do, now what this code is gonna do, if we read through it, we're gonna enter the loop and we're gonna move forward first. And then once we've moved forward, we're going to do a test. We're going to say, hey, if we're not on a gem, turn left, move forward twice, collect the gem, turn around, move forward twice, and then turn left. So kind of reset yourself. But if that's not the case, what are we going to do? We'll just drop off the end here, go back up to the top, move forward, do our test again. If we are on a gem, we'll drop down here, no more code to run, back up to the top of the loop. Let's try running this and see how this works. All right, we got a reset Hopper. Okay, especially when do you know what we're forgetting? There's one thing that we want to do though when we are on a gem. So in the condition where it's the opposite of this one here, because we did a great job collecting the last gem, but we're not collecting the gem all the other times that we're on a gem. So how are we going to accomplish that? Well, we could add an else clause. So if we're on a gem, which would be the opposite of this not is on a gem, we could do something. So let's add an else statement. And let's just collect the gem. Okay, start running my code. And in fact, let's step through my code so we can watch what's getting run when. There we go. Okay, down to the else clause. We're collecting the gem. Back up to the top, we move forward. We're testing to see if we're not on a gem. We're on a gem. Hopper goes and collects the gem. Again, we've collected the gem. We still haven't fallen into the not is on gem. Now we've fallen in there. Then we've come back up to the top and we've turned forward. Perfect. Okay, so we had a few mistakes to start out with to figure out how do we get this code to run? How do we solve this puzzle? This is kind of an interesting one because we might get lucky and maybe some of the code we write would solve one particular case. Like if the not gem and the stairs were at the very end, we might have had a different result. But I think this will work in pretty much any case. Let's try running it again just to make sure with a different setup we'll still solve it. This is a big part of testing your code, is anytime you write new code, you kind of have to test it. When you have conditions like this, there are lots of different branches that we could go down. And we call it a branch because it's a little bit like looking at a tree, where the tree starts out at the trunk and then things diverge and they go off down different paths. We have to make sure that the code on each one of those paths works well in the condition that we expect it to work in. Okay, so we can tap on these blue links like I mentioned before, and we can see that, okay, an exclamation mark inverts the Boolean value of a piece of code. And I like the example here because maybe that isn't super clear. If A is true, then not A is false. And this is where it helps to be very clear in your variable names and have them almost make sense from an English language point of view. Because when you go back and read it over, you want to make sure that you can say, okay, well, if not is on a gem, that kind of makes sense to me from just an English language perspective. All right, so that's the logical not operator. Now what we're going to do is go up to the table of contents, tap on using the not operator text. We're going to skip over spiral of not, and we're going to go checking this and that. So let's tap on that one. Okay, so this is a bit more involved because it's got more text here for us. So it's saying, all right, so the goal is to use the AND operator to combine two conditions and adjust your path if both are true. Okay, so we have a bit of text we can tap here to learn more about the logical AND operator. So in this case, A and B is true only when A and B are both true. And we can try this out. The nice thing about these puzzles is we can kind of feel when the code is getting run by using that step through our code function over here in the little speedometer. Okay, so here are our directions here. So we have a new condition called is blocked left. Okay, so Hopper's going to start out here and go this way. And there's an is blocked left. And it looks like every time we're blocked on the left, we have something to go down and find on the right. There's a switch. And it looks to me also that these switches, some of them are toggled on and some are toggled off. So we want all of these to be on at the end of this puzzle, and we want to collect all 6 of these gems. So let's try it out. Let's write some code here. So let's see. So the Boolean condition is blocked left. We got that part. Add an if statement in the for loop, then add a condition to check whether we're on a gem. All right, so let's do that first. I just tapped here at the end of the brace. I'm going to hit the return key over here. And I'm going to add an if condition from the autocomplete bar. So let's see. So add it to check whether I'm on a gem. So if is on gem, what am I going to do? Well, would be to collect the gem, right? Or do we want to add a second condition? Let's add our second condition like they're asking. So you can see here it shows up when I'm at the end of the is on gem and the cursor is blinking there. I have an option. I can either say is on gem again, which is fine, just adds a space. And now I have the option to tap on the ampersand sign. So I'm going to tap on that. And it fills in, it tells me that it's looking for a Boolean, right? So these are all the Booleans that I have available to me in my playground. So I want to see if I'm on a gem and blocked on the left, I'm going to turn right and toggle the switch. Okay, so I'm going to say is blocked left. I want to turn right and toggle the switch. Okay, cool. So let's do that. So we'll scroll over here, pick turn right. Now, we've got to move a few to toggle the switch. So let's go do that. So if we're on a gem, and we're blocked left, we're gonna ignore this one because this one is on. And that's why we came up with this particular condition. Because if we're on a gem, well, we don't want to turn right every time. We only want to turn right when we've got something blocking our left. And we don't want to do it just when we're blocked left, because if we go walk down there, that switch is already on, so we don't want to toggle it off. So we want to turn right. We want to move forward twice. And then we want to toggle the switch. Then we want to turn around and come back. So turn left, and then move forward twice again. Okay, and now we're back on here, but we're facing this side here, so we want to turn right again. Well, best way to try out our code and see if this works is to run it. So let's hit run my code. Here we go, hopper's going. Oh, we're not collecting gems, forgot about that little piece. Nope, so we're on a gem. We've gone up the hill, toggled the switch, turned around. Okay, cool. Well, we've solved that piece of the puzzle anyway. We're just missing our collecting the gems now. Now, how are we going to do that? So we also didn't, maybe we did our condition too soon. Just like last time, right? So what we're going to do is tap on move forward, press and hold, so I can grab it and drag it up to the top. That's not the only way you could do it. You could also delete that and then just force everything else down by hitting return at the top. Okay, so this will now move us forward, and we'll actually run that last bit of code too. But we're still missing the fact that we're not collecting gems. So what we'll do is we could say every single time we move forward, we could try to collect the gem. We could add another condition here. Say, okay, if is on gem, collect the gem. That might not be a bad approach. Let's try running this code. All right, there we go. Let's see, we're running this part first because we checked to see if we're on a gem and we're blocked left, we would run all this code and come back. Then we check again to see if we're on a gem and we collect the gem. Maybe you want to move that is on gem up further. There's another way we could write this too. There we go. Hopper collects that last. Oh, not the last yet. Now, because we move forward up first, we move forward, then we do this check. That's why we actually ran the code on the last step now. Excellent. So we've managed to complete that puzzle with this condition, with a logical operator, a logical AND operator. Now, if you go tell your teachers that, or if you are a teacher and you go tell your students that you just wrote a logical AND operator, you'll blow their minds and maybe scare them a little bit. So there's another way that we could write this. And we remember we had that else if conditional coding piece that we worked on way back on, I think, day 3. If we tap on this closing brace here, we can say add else if statement. And we could have checked to see if we were on a gem there. So what would happen is Swift would read down through here, move forward, run that code, come down here and say, okay, if is on gem and is blocked left, if either one of those was false, so if we weren't blocked left or we weren't on a gem, it would drop down here and say, okay, else if I'm checking to see if I'm on a gem. So this might be true still. We just might not be blocked left. So if we added this code, what do you think is going to happen? Here, let's delete that code. Actually, let's delete this whole condition here. We're going to collect our gem here. This is another way to write it. Let's try to run it and see if that works for us. So we're going to close the congratulations message. We're going to run our code again and see what happens. Hopper starts at the beginning. Oh, we fell into this condition here. We're collecting. Okay, so we entered into here because we were both on a gem and we were blocked left. So we went and toggled the switch and we came back. There we go. Now we have a minor bug in our code because what we did was we left behind that other gem. So maybe the first way we wrote it would be better because we do that check after this whole thing. But this is just to highlight to you that if you're doing a block like this where you have an if and an else if and an else, you're only going to run one of these blocks in here. So even though is on gem is true, I'm not going to run it because I already ran this block in here. So that's just one thing we need to think about. So we either need to add a collect gem to this particular piece, or we have to add another conditional at the end to check to see if we're on a gem. Just something to keep in mind when we're trying to solve a puzzle and we've got a lot of different conditions to consider. It might make sense to say, oh, actually, I want multiple if statements, not just one big if statement with a bunch of else ifs, especially in puzzles like this. All right, the very last thing we're going to do is we're going to go check out the OR. Just while it's fresh in our mind, we'll check out the OR. We'll go back over this again a little bit tomorrow. So if we go up to the menu, I'm going to go tap on the checking this or that. Okay, and now we're going to use the OR operator to adjust our path if either of two conditions is true. So we're going to check and see if we're on a gem or if we're blocked left, we're going to move forward. That's what this conditional here would do. It's because we need to figure out how we get Hopper from here through this portal to collect that one gem. We've only got one gem to collect. And we've got a loop here, so we're going to do it in 12 moves. So let's see. Here it says, step 1, use the OR operator to check whether one of two conditions is true. Hint, you might be blocked either in the front or on the left. So let's go down here. And one of our big mistakes is we weren't moving forward first. So let's move forward first. Okay, I've just been informed that this might be a little bit of information overload. I think we've done a really good job to get to the AND logical operator and the not logical operator. Tell you what, let's take a little break and come back to the checking this or that playground page tomorrow. I think you've made huge progress. This is a massive thing that you're going to use a ton when you're programming to check different types of conditions. It makes you look really cool if you start using double ampersands or double pipes or exclamation marks in front of your Boolean variables. You're one of the cool kids now. So we'll leave it at that for today, and we'll come back with the logical OR operator tomorrow. All right, we'll see you tomorrow.